guys, and welcome to this video on dot matrix displays. This is a breadboard I've made up. It drives an 8x8 dot matrix display using two 74HC595 shift registers and a ULN2003A transistor array, and of course the Arduino Micro, which I detailed in my last blog post. If you want to find out how this works, stay tuned. There's going to be a little time lapse of me building it first, and then I'll go through an explanation of how it works and what can be done with it. Enjoy! So, having watched the time-lapse of this breadboard being built, you'll probably want to know how this works. As I said earlier, there's an Arduino microcontroller, two 74HC595 shift registers, and a ULN2003A transistor array, and also a transistor because I didn't have enough transistors in the array to drive 8 rows. This board consists of a row driving section and a column driving section over here. The Arduino outputs serial data to the 74HC595 shift registers, and they convert it to parallel data and send it out on each of their 8 pins. So, for example, if the Arduino Micro outputs 10100000 to this shift register, then 2 of its pins will go high and the rest will be low. What this does is it drives this transistor array, and if the array gets a high signal at its input pin, then it puts a low signal on the corresponding output pin, thus pulling one of the rows low on the dot matrix display. Obviously they're through current limiting resistors, just to make sure that the display doesn't draw too much current and blow anything in this circuit. If serial data is outputted to this shift register, for example again 10100000, then the pins of this shift register are driven high, except it's not driving a transistor array, so it just drives one of the columns high. Now we know that an LED needs a potential difference of 2 volts across it to light. So essentially, if say column 1 is high, is being driven high by this shift register, and row 1 is being driven low by this shift register and this transistor array, then the top left LED will light. Now that's all well and good, and it means we can drive individual columns and rows high and even individual LEDs, but we can run into problems. Say for example I wanted to light this LED here, this LED there, but not this LED in this corner, so I've made a little square. I would run into problems because I would be able to light these 3 LEDs, but this LED would also light always as a consequence of me wanting to light all the other ones. So I can't do this in one go, I have to kind of do it in stages. And this is where the technique known as multiplexing comes in. I'm fairly sure I've detailed multiplexing previously in a blog post, but I'll just go through it again just to make sure that everyone understands what's going on in the context of a dot matrix display. So at the moment, to both me and the camera, this display looks like it's a constant static image, and in fact that's not the case. So I'm just going to slow down the speed of the display to show you exactly what's actually occurring to make this smiley face appear on the display. So all that's happened here is the speed of the display has been slowed down. Now as you can see, what's actually happening is the eyes are being displayed, then the kind of sides of the mouth, and then the bottom of the mouth. Now this looks very stuttering, you can't really tell that it's a smiley face at this speed, but previously I was running the display that it would update each of these individual parts at pretty much 1,000 times every second. So there's only really a delay of about 3 milliseconds between the whole thing. Now what this means is that because it's updating so fast, the human eye can't perceive the change, so it just shows us all of the LEDs being lit at once, when in actual fact what's happening here is that each section is being done individually. Why does this help? Well, what it means is, if I go back to our earlier example, if I want this LED lit, this LED here lit, this one lit, but not this one lit, what I would actually do is light the two LEDs in this column and then the single LED in this column, and that would stop this LED from lighting because I chunked it down into two separate parts instead of trying to do it all at once. This smiley face would not actually work if it wasn't for the technique called multiplexing. You couldn't do it because LEDs would be lighting in aggregate all over the place, just because I'm trying to light these particular ones here. So you must do it in separate stages to get the image to light properly. So that's how this system works. I'll just show you a few examples of what this can be used for and talk about how you may have seen it in real life without really noticing that it's there. So one of the biggest uses for these kinds of displays is displaying text. As you can see, there's the letter A there. I plan to get scrolling text coming up soon. You will have seen that in shop windows and things like that. Scrolling text is always really eye-catching and very interesting. Text works on these displays because you have kind of the individual dots, which are essentially like pixels on your TV screen or anything else. In fact, this is very much the same concept as how the pixels on a TV screen actually work, although the science behind it is different. These are just LEDs. But it works in the same way that there's kind of individual pixels which come together to form one image that we then see. So displaying text is one of the very common uses of these displays, and in fact if you walk into an electronics shop you may well see one of these just on the wall scrolling some messages. People even link these up to Raspberry Pis and get them to display the latest tweets to their timeline and things like that. But it doesn't just have to be static images. We can actually use a slower update rate to our advantage and make a moving display, as you saw at the start of this video. The start of this video was actually a different board, which was just the Arduino Micro directly driving the display, but it's the same concept. There's a moving image that you can see here. Now in actual fact, nothing is actually moving here. Again, it's much like how your TV works, it's a trick of the eyes. These LEDs are updating and changing so quickly that the human eye can't help but see it as one moving image of squares moving across to the edge of the display. So guys, I hope you enjoyed this video. I hope it helped you understand how these things work, and when you see one in the street you might kind of see what the complexity of actually driving one of these displays. They can actually be chained off of each other, so you could have, this is an 8x8, but you could have two 8x8s next to each other to make a 16x8, or even further than that, like a 144x8 or something like that, depending on what displays you use. They don't just come in 8x8s, they come in 5x7s, 5x8s, and other varieties, different colours, 2 colours, 3 colours, etc. You can get a full RGB one which can then be used to display kind of full colour images, much like how your TV screen works. If you want more information, then please go and read the blog post that goes into detail about the chips and how they work. And as always, thanks for watching, and I'll see you in the next video.